Howdy, boys and girls. This is Mrs. Dunn. Today I'm going to be talking about graphing inequalities and solving with inequalities. So up until now we've been looking at and solving equations and looking at expressions. And equations are solving for an unknown variable to get one answer. Inequalities work a little bit different. You got two foldables. You have this foldable here, and you also have this foldable here. So let's make sure that you have them. I have them on two separate papers. We're going to look at first writing down the definition of an inequality. So the definition of an inequality is a math sentence showing two quantities are not equal. Let's see if I can focus that a little bit better. Sorry there. Oh, there we go. Okay, so it's a math sentence showing two quantities are not equal. So instead of an equal sign when we're looking at an equation, we're going to have different signs. So the signs that we see are these greater than signs, the less than sign, the greater than and equal to, and the less than or equal to. Those are the signs that we're looking at when we're talking about inequalities. And hopefully a light bulb went off in your head and go, oh yeah, I've seen those before. Okay, so what we look at, and we're going to be taking a while to look at inequalities, but we're looking at trying to find what numbers match with our inequalities. So this first page is just three inequalities and a number line. The great thing about inequalities is we don't have just one answer. We have a multitude of answers. So for this first one, I have the x and the 3. Now, x is not equal to 3. It says that x is greater than 3. So I'm going to write that. X is greater than 3. So if x is greater than 3, I need to graph all the numbers that are greater than 3. So I look on my number line. I find the number 3. Now, x is not greater than or equal to 3, so even though I start at 3, I'm going to put an open circle. This open circle tells me that 3 is not part of the solution, but it's where I start. Okay, and then I draw an arrow. So my solutions are not just one point. They are a point with an arrow going in the correct direction. If x is greater than 3, all my numbers should be greater than 3. In this case, I'm going to the right. So I'm talking about all the numbers to the right of 3. So that's 4, that's 5, that's 4.5, that's 6, that's 10. Every single one of those numbers is greater than 3. Okay, let's look at the next example. Our next example shows an x and a negative 2. In this case, x is less than or equal to negative 2. Notice the closed end is closer to the x. That means the x is smaller. So I'm going to write x is less than or equal to negative 2. Notice the difference between my two symbols here. This one's a greater than, this one's a less than. But notice that this one has this line underneath. That line saying it can be equal to negative 2, and it can be less than negative 2. This one says it's only greater than 3. It cannot be equal to 3. So that or equal to is included whenever we have that line. So if it's at negative 2, I'm going to go over here to negative 2. Because it can be equal to it, that dot is going to be closed in. So I'm saying I can include the number negative 2 this time. And my values of x have to be less than negative 2. Less than means I'm going towards the left. So I am going to be looking at numbers less than negative 2, so I'm going to be going this direction. Okay. Now usually I put our lines on the number line, but I just want to make sure that you can see them. So we're talking about any value that is less than negative 2, like negative 3, negative 4, negative 5. But it can also be rational numbers between each of those digits. Okay, let's look at the next one. Hopefully we're seeing now that this line means equal to, and our inequality sign is showing a greater than. So this is x is greater than or equal to 1. Okay, since it's at 1, I'm going to put it on 1. And I have to decide, am I going to have an open circle or a closed circle? An open circle, like at the front, this top part, is whenever my inequality does not have an equal part. The closed circle, like my second example, is whenever it does have that equals. So if I look down here, this has an equal sign, so this dot needs to be closed because it does include the number 1. X could be 1. It can also be any value greater than 1. So greater than, I'm going towards the right. So my line's going to go towards the right. And that's graphing inequalities. That is different than graphing an equation, which just gives me one answer. Inequalities give me a lot of answers in one direction. Okay, so that's a little bit of graphing inequalities. We're going to work on those more in class. I'm going to turn over my page and go to solving inequalities. We should have this piece of paper folded and cut correctly. I've titled it Solving Inequalities, and I've put this 4 flaps. I've went ahead and rewritten my problems underneath each flap so that it's a little bit easier for me to get started with. Okay, so I'm going to start with this first one right up here. It says 0.2a minus 3.5 is greater than 7.1. Notice what we're talking about has rational numbers. Those have decimals, so we haven't really looked at solving equations with a lot of decimals, but we can do it just the same. Solving an inequality and solving an equation are very, very similar. So to get us started, this is actually a 2-step equation. So to make it a little bit easier on us, because we're just working with 1 step, I'm going to cross out this 0.2, and I'm just going to make it a. Okay, and this is the only one that got a little messed up, but I'm going to say a minus 3.5 is greater than 7.1. So I'm going to look right here. And it works the same way. I'm trying to figure out what a is. Right now it has that minus 3.5. So I'm going to have to take the inverse of that minus 3.5, and the inverse is a plus 3.5. So I'm going to add 3.5. Now, it works the same way. What I do to one side, I'm going to do to my other side. Even though it's not equal, it's greater than, I'm still going to treat it the same way. So I'm going to add 3.5 to the other side. These cancel each other out. I'm left with a. And I have, bring down my decimal because they're lined up. 1 plus 5 is 6, 7 and 3 is 10. And my a is not equal to 10.6. My a is greater than 10.6. I have to bring down that inequality. So my answer is a is greater than 10.6. Okay? That means any value greater than 10.6 can be a value for a. All right, I'm going to turn this sideways to look at this addition problem. And you're going to see that they work exactly the same as our equations did. So I'm drawing my line down. It's y plus a value. So to get rid of that, I take the inverse, the opposite of adding, which is subtracting. So I'm going to subtract 3.2. What I do to one side, I'm going to do to the other. Notice, because I am subtracting with decimals, I'm lining up my decimals. Okay, these cancel out. I'm left with a y. When I subtract here, 5 minus 2 is 3. Bring down my decimal. 7 minus 3 is 4. Bring down that 1. And I'm left with 14.3. Again, y is not equal to 14.3. Y is less than 14.3. So I'm going to write that. Y is less than 14.3. Okay, so we've done a subtraction, we've done an addition. We use the inverse operations. Let's go over here to this multiplication. So it's saying 2 x's are greater than or equal to 5.42. To figure out what 1 x is greater than or equal to, I am going to have to do the inverse operation, and the inverse of multiplying is dividing. So I'm going to divide both sides by 2. Okay, well, I have to do this over here. I'm going to do top in, bottom out. So 5.42 and 2 on the outside. I'm going to bring my decimal up. 2 goes into 5 2 times, minus that 4 out, subtract, bring down that next 4. 2 goes into 14 7 times, because 2 times 7 is 14. I subtract that out. I'm left with 0. I'm going to bring down that 2. And 2 goes into 2 1 time. So I have discovered that 2 over 2 is just 1x. 5.42 divided by 2 is 2.71. And again, it's not equal to, it's greater than or equal to. So x is greater than or equal to 2.71. X is greater than or equal to 2.71. Okay, and I did that by finding the inverse, and that the inverse of multiplying is dividing. We have one more. This is dividing, so we should know and feel pretty confident the inverse of dividing is multiplying. So I rewrote my problem, and to figure out this, I'm going to multiply both sides by what I'm dividing by. So I'm going to multiply by 2.3. I'm going to multiply by 2.3. Not only do I have a rational number, but I also have a negative value. So I'm going to have to use my integer rules with this too. This is easy. 2.3 over 2.3 is just 1. So I'm left with my b over here. I'm going to have to do some math. So I'm going to go ahead and put that 5.1 there. 2.3. I'm going to multiply. 3 times 1. 3 times 5, add a 0, 2 times 1, 2 times 5, add those up, move that a little bit, 3, 7, 1, 1. I'm going to have to move my decimal in, so I have to remember my decimals. I count 1, 2 decimals places, so I'm going to move back in, 1, 2, and I'm at 11.73. So 11.73, 11 and 73 hundredths. But I have to remember my rules for integers. And if I'm multiplying a negative and a positive, my answer is going to be negative. So this is going to be a negative 11 and 73 hundredths. And I'm not going to say it's equal to, I'm going to say it's less than or equal to. Okay? If I went too fast for you, rewind, look at it again, check your numbers. But my b is less than or equal to negative 11.73. So my b is less than or equal to negative 11 and 73 hundredths. Okay, so I have done one of each type of problem, all inequalities. Notice they are solved exactly like equations. I just bring down that inequality when I'm done. Okay, so when you are ready, we're going to open it up to that blank side. I am going to write WSQ. Let's remember that, guys, a whisk is a sentence that you are writing about this video that we just watched. So write a sentence here. Do not just leave that blank. Don't write the words or the letters WSQ and then not write anything. Okay, and then our check for understanding. I will just give you 2 of them, okay? I'm going to give you 1 is a plus 5 is less than or equal to 17. And then 2, 3p is greater than 21. And I want them to be solved and graphed on a number line. So solve and graph your answers. I hope that we understand this. We're going to be practicing it in class later on in the week. So thank you for listening.